do it in Clojure. So in GraphQL, you have a schema, you have queries, you have mutations, you have subscriptions. Queries are pretty obvious. Mutations are anything that's going to update or change the underlying data. And subscriptions are basically ways to get data sent down a WebSocket to update your application. And this can be used both for a front end of some sort, meaning a web browser front end, a mobile device. You can also use GraphQL to do an API. In fact, many of the things in GraphQL remind me of things that are available in Swagger, which to me is a good thing, actually. One nice thing about the schema is it provides a structured way for the people who are doing front-end work and back-end work to communicate about what the data really is. I've seen that be a confusing factor where somebody builds some kind of an API and it's not very well documented. And you start sending data over and, oh, I didn't expect it to be like that. That's not what it said in the documentation. Well, if you have a schema, you can just use the schema. Some of the libraries on the front end actually use the GraphQL schema, and some don't. The one I chose to use for this did not. There's one from a company called District 0x that uses the schema, but it only, last time I looked at it, which was a few weeks ago, it only supported queries, no mutations, no subscriptions. I'm not going to go into subscriptions in any detail today. There's only so much you can put into 45 minutes to an hour of talk. Okay, so let's talk about the schemas. So this is a schema I used, this is part of the schema I used in my application. And there's no use in going through the whole thing, it just won't help anything. But you start off with, there it is, the schema, and you have queries and mutations, and all this does is tell you where to look for the queries and mutations. I created an enum, and it's not showing up on the screen. Very, very bad. So the next thing I did was create an enum, and that has, for roles, you can be a client or an administrator. I defined several types. I'm showing only the type event. We'll be working mostly with the type people and somewhat person, somewhat with the type event. But the event has an ID. The exclamation point means it's required. It means non-null. So you have the name's a string, you have a date, you have an int, and you have a list of people, a list of persons for people. So the brackets are used when you have a list. Very much like Clojure. Some bad news things about using GraphQL from Clojure: dashes don't work in names. It wants them, it really was started with JavaScript. It loves camel case, and it will live with underscores. But it will blow up if you use dashes. I did find a library called camel snake case that will actually translate automatically in most cases, camel case and snake case stuff, to dashes. I chose not to use it. One reason is because I used SQL database for this. Guess what? SQL doesn't like dashes either. So I just used underscores, and both GraphQL and SQL were happy. It makes my life a little more difficult as a programmer, but not that big a deal. So going on, there are objects like the type I just showed for events. Then there are input objects. Input objects have restricted capabilities. You can't have lists, you can't have a few other things, but basically they work the same way. This is for inputs to mutations and query, arguments to specify what you want. You can list everything out as arguments, like a function with 20 arguments if you want, but that is not the greatest thing when you get a lot of them. So you can put them all together in an input object and pass that along to your query or mutation. So here are some queries I had. I had a query for people, it gets all the people. A query for person, where you pass the ID, and it gets you one person with that ID. The same thing for events. And I defined a whole bunch of mutations, basically to finish CRUD. So you can update a person, you can create a person, you can delete a person, same thing for events. You can associate a person with an event, and you can disassociate a person with an event. So this what I had in mind here is you have a bunch of people, you have a bunch of events, somebody can register for an event. They can register for your meetup or for a tennis tournament or whatever it is you want to do. But you have to define all these queries and mutations in your schema, which may seem like a pain, but it's also a good thing because that way you don't have to provide a totally general query and update engine. And it's a good thing for security because you can only ask for mutations and queries that are specified in the schema. So if you ask for a field that may be in the database but is not in the GraphQL schema, it will give you an error. It won't get it. If you want to mutate something and it's not a defined mutation, it doesn't work. It won't do it. And that's one of the things that when I first started looking at GraphQL, I was really worried. How am I going to deal with stopping people from mutating things I don't want them to mutate? And the answer is, if it's not in the schema, it's not going to happen. Okay, so I guess you can't see this very well. Let's see if I can blow this up. There's this cool tool called GraphQL or GraphQL. And what I'm showing here is its use. On your left, you'll see a query. And that is the people query. So it starts off with people, and then I have a curly brace, and I list the fields I want out of people. In this case, it's all of them. And when I hit the little arrow button, it pulls up all the people and all the data for them. In the middle, that was in the middle section. In the right-hand section, there's a help thing. This is where it looks like Swagger. You can actually, I tried, it's not doing it. Unfortunately, it's not doing it. On the right, you can choose, you can go look at all the documentation. It allows you to look at what all the queries are, what all the mutations are, what fields are in the types, and if you apply doc strings, you can see the doc strings. So this is very nice if you have somebody who's working on the client for GraphQL, who's not the one who programmed the server. Because if you provided decent doc strings, the client programmer can just try their queries and their mutations just by typing them in here, pushing the button, and away it goes. And you can see if what you did is right or wrong, whether it works, whether it doesn't work. I've had some situations where I was working with REST APIs, things weren't very clear, and it was very difficult to figure out what the people who did the server side, who were in a different company, actually intended for it to do, because it didn't do what I thought the documentation said. So, and the bottom left box, as you see it, is where you put variables. That's a very nice thing about GraphQL. You don't have to build the values into a query string or into a mutation string by doing a bunch of string manipulations. You can provide them as a separate set of variables, and it will pick them up and actually use those values. Back in the old days, you used to have to build SQL strings up actually by doing string manipulation. I've had to do that a few times. So before they had the question marks where it would sort of fill it in. That was very painful. Okay, so this just shows if you only ask for a few fields, you only get a few fields back. Pretty simple. You can provide a subquery. In this case, let's see if I can, it's not doing it either. Oh, this one doesn't work by touch, does it? If you ask, in this case I did manually associate some people with some events. So when I ask for people, I can specify the field events and then put the curly braces in the fields out of events I want. And it will get the people, and it will also get the specified fields out of the events that they're in, which is a very handy thing. You don't have to join this stuff all yourself. Interestingly, many of the libraries for client side take this kind of stuff and automatically normalize it and pull it apart. If you look at how Apollo works, how Relay works, they talk all about normalization. That's ripping the stuff apart and putting it into separate places where they're going to join it back together again. Another nice feature here is you don't have to get data you don't want. So if you have one application that only uses half the data, the other application uses all the data, you don't have to send it all to the thing that only uses half the data, which can be very nice if you have a mobile app with this and somebody's on 3G still, or they have a slow link, a lot of interference. Even if you have a nice LTE link, if you're coming out of Silverthorne going up to the tunnel on a Saturday or Sunday afternoon during ski season, don't expect to get much data because it's not going to come. It's way too congested. So you can do subqueries. Yes, GraphQL. Well, it will solve the problem of only retrieving the amount of detail you want, or amount of data you want. It won't solve the problem of there's not enough bandwidth, because there are literally 5,000 people trying to use 1 kilobit of bandwidth. Right? There's nothing that solves that problem. But you can solve the problem of not retrieving all the data that's there if you don't need it, which can help when you have slow links. Or if you had some situation where for some reason it was expensive to transmit data. Right? My wife works for a large telecom company, and they have certain clients that want connectivity to oil rigs, in the North Sea or something, and bandwidth is limited. Limiting the amount of stuff you send is actually very useful in those cases. So mutations basically are the same thing as queries in the GraphQL. When I showed the queries, unfortunately I can't blow this up, it's annoying, but the query, if you want to do a basic query, you can just supply the fields you want and it will get it. For mutation, you cannot do that. You have to use the word mutation. You can also use the word query and set it up like this if you want, but basically you give it the arguments to the bigger mutation, which refer to the variables, and then you call the actual mutation function, and away it goes. And it works actually pretty well. If you mess up, you'll get an error structure. And this is an example of an error structure. I asked for a field that didn't exist, so it tells me the field doesn't exist. And it tells me it's an error. The server-side library I use will actually pull all this stuff out, and you can find the client-side library will pull this out, and if it'll provide all the errors in an error argument and all the data in a data argument, so you can see if there are errors. You can look at the error messages. You could actually take the error messages and supply them to the user in the form as errors if you wanted to. It's pretty flexible. So now talk about the app a little bit. I used Reframe in the browser. How many people here are familiar with Reframe? We had a talk about this a few months ago. Okay, so Reframe is basically an implementation of the Elm architecture in Clojure. The Reframe author claims he predated Elm. I'm not sure what the Elm people would say, but it provides a very nice framework around reagent, which wraps React to handle all the data updating in the browser. I used Walmart provided, I used regraph, which is a library that goes in with Reframe. All it does is provide the mechanisms for setting up GraphQL and sending GraphQL queries, subscriptions, and stuff down. Just a couple, if anybody wants to use this stuff, just a couple issues. One is regraph really wants to use a WebSocket. You can make it not use a WebSocket in the configuration, but it really wants the WebSocket. And so just keep that in mind. Also, I found some bad interactions between Figwheel and regraph. It basically makes Figwheel reloading not work right. When you call the setup parameters for regraph, Figwheel wipes some of them out every time it does a reload. I don't know why it does that. But it was a CORS parameter that gets wiped out every time. The URLs stay everything, but this one CORS parameter gets wiped out. I could work around that if I wanted to by changing how CORS is handled on the server side. But that was very annoying. Other than that, regraph works really well, and it's really simple to use. It fits very well with Reframe. This District 0x library looks like it's really good because it has all the handling of the app-DB built into it for Reframe, which regraph doesn't have. It just wishes it handled mutations and subscriptions. So I recorded the app running. See if we can make it run. Unfortunately, my artificial intelligence types in slow motion. But it's a typical thing. You can type in all the data, and you can just save. And it will save it. The data shows up on the left. You can pick a person on the left, and you'll get their data. You can change some of the data and hit save, and it will update the data automatically. And that's done with GraphQL queries and mutations. Basically, I queried for all the data up front, pulled down all the data about people. That's kept in the app-DB. Whenever anything is changed, it calls a GraphQL mutation, updates the server, and when you do a mutation in GraphQL, you not only specify the mutation and the variables, but you can also specify a query to be run afterwards. So I just had it send the data back that I had just created. And that's actually a very handy thing too, because if you're not trying to do optimistic updates, you actually know what happened on the server because you can pull the data back, as well as potentially getting errors. So, for those who aren't familiar with Reframe, it in many ways does the same thing as a bunch of the Apollo libraries. Well, not Apollo does it, and a lot more. A bunch of JavaScript libraries used with React do this kind of thing. You have an app-DB as an atom, and the app-DB contains all your application data. You can still use reagent stuff. You could use local data in your reagent objects in the atom if you wanted to, but really Reframe is designed to put everything in the app-DB. You have subscriptions. Subscriptions take data out of the app-DB. They also can transform the data in the app-DB into a different format. So if you wanted to upcase stuff and so forth, you generally would be doing that in a subscription. The views use the subscriptions to access the data they want from the DB. It is considered bad form, really bad form, for a view to directly look at the app-DB. Views generate events. For example, when you click a button, you'll generate an event, and there's a whole file full of events. And events will update the app-DB, so you get in the cycle. You can also have events that are triggered from external stuff. For example, some data coming in from a request to a server. And that's the basics of how Reframe works. If you want more than that, you can probably find Ian's talk from 2 or 3 months ago. It explains Reframe in great detail. So the demo's not going to look like much, but the box on the right is a Reframe 10x box. And that is this fantastic tool that allows you to see exactly what's happening in your application. You can see the results of every subscription. You can see all the events that are called. You can see how long it took to do things. And as you run these things, for example, I changed my filter box. You'll see that the data changes. This in the app-DB. The subscriptions all change as I change my filter, because one of the filter items is actually what is going to be shown in the list. And it has this really cool time travel debugger, so you can go back through the epochs and see what the data actually was 3 things ago. So if you're going along and something's not working, you realize some piece of data is wrong, you can actually keep going back and see where it went wrong, which is extremely handy. This is a great tool. This is the thing that Elm really had over Reframe, is the time travel debugger, and the Reframe 10x makes refrisk look terrible. And it really gives you a tremendous ability to debug things. To create a new Reframe app with Reframe 10x is very easy, as long as you use the line again template. I had a terrible time wasted a lot of time trying to add Reframe 10x to something that had been a refrisk app. And I never did get that to work. I ended up creating a new app and copying everything over, copying all my code over. Something was wrong on my project SCLJ. I have no clue what it was or how to find that problem, but yes. Yes. The ENS is HTTP abstracted out by the regraph library. The question is yes. The answer is yes. So let me answer that in two ways. One is the effects actually show up in Reframe 10x. So you can see, and you can actually look at if you look up in the box at the top with the event, you actually see the GraphQL that it was trying to send across. So it's actually not too bad. The second thing is if I bring up, when I get in a lot of trouble on network requests, I just bring up a network analyzer. I forget which one I have in there, but I have actually a couple. And I'll just put that in the localhost in between and actually watch the TCP IP go past. And it's sane. It's GraphQL, you can encode GraphQL a whole bunch of different ways legally. Everything I've ever seen encodes as JSON. So essentially what you see is JSON coming across. Okay, so then you can tell exactly what's happening. It's not like transit where you get this bizarre stuff that you can't figure out what it means because it's compressed, and I think you know exactly what I mean. So yeah, it's very, what you see is very sane. It's actually not hard. I was having problems with my GraphQL mutations not doing what I thought they should, or they actually giving me errors, and I didn't know why. And then I realized that I could actually see the mutation that was sent across in this box right here as an event. Like, oh, now I know. I was able to see what was going on, and I realized that what was really happening is I had failed to ask for a field that I needed. That was very nice. Okay, so now this is more readable, fortunately. I have some actual code snippets out of the working application. And so from these you can probably tell if you're familiar with Reframe and slightly familiar with GraphQL, you can tell sort of what's going on here. So to get this piece of it has nothing to do directly with GraphQL, and that's one of the reasons I put it in here, is the subscriptions pull things out of the AppDB and make them available to your views. With regraph, you do not use GraphQL to read the AppDB. You just take the data and you bring it into your application. So you can see all I'm doing is for a filter, I'm doing this filtered list of people. I have two subscriptions. One is to all the people, and to something else called the person role filter selector, which is really just the value in the dropdown. It says administrator, client, or all. And I simply call a function that goes across the person list and looks for things that have a matching. Either if it's all, it will just return the whole list. If not, it will look for things with a matching role. So it's actually very simple to create that, and there's no GraphQL in here at all. If I look at some of the other GraphQL things I've looked, like in Apollo, you might actually save all your not server data, all your local data, and this goes in your data store with GraphQL mutations and retrieve it using GraphQL. So it's a trade-off, right? Do you want everything to come through GraphQL? It looks like it's all GraphQL. Or do you want GraphQL to be a medium for communicating with your server? Regraph chooses to make it a medium for communicating with your server. Okay, so the view, I have a couple snippets out of a view. And these are snippets that actually do have something to do. The bottom one has a lot to do with GraphQL. The one up top is simply the view code that's associated with the subscriptions that I just showed you. right, you subscribe to the role filter selector, you create divs, you create a select, and there's a, when you have a change, this is just like the on change in React for those who are more familiar with JavaScript, it will, using JavaScript interop, it will dispatch a reframe event. Remember I said views create events? Now you could, programmatically it's possible to go in and twiddle around with the appdb from the view. That is a very bad practice. It will lead you to grief in the reframe world, and the debuggers won't work right. But all it does is do some JavaScript interop to pull the value out and pass that to the update person role filter event. No, that's actually a mutation. The way so the second is a snippet. The second little piece there is a snippet I took out of the view. It's the buttons that say, it says save. So when you hit the save button, you'll see you have this event. You have a button that's called save. It's disabled if there's nothing there. It has, well, get class disabled. On click, there's a function that's called, and it does the typical JavaScript stuff with stop propagation and prevent default. Then I'm looking at if the ID blank. If the person doesn't have an ID, it's a new person. If the person has an ID, it's an existing person. So I'll either send off the mutation to create a person or send off the mutation to update a person. They're almost the same. And so you can see I have the variable new person, which is an input person. That's the reference to the variables that are passed along. And then you have calling the create person mutation and pass the new person to it. And then you have this thing where you have the curly brackets ID, first name, last name. That's the query for the data coming back. Now, in the events, when things come back, I'm normalizing the data based on ID. So I have to make sure that I always ask for the ID of stuff coming back. And when I create or updated something, I don't necessarily want to have to figure out what fields I changed. So I just ask for it all to come back. It will get written in the appdb with whatever values come back from the server. I was not careful about handling errors for the purposes of this talk. That would just be a whole bunch more code to confuse everything. So I dispatch a regraph mutate or a regraph mutate event, which will cause that mutation keyword to get thrown in there automatically. And it causes the HTTP stuff to be triggered. So I'm triggering an event. I pass it the mutation I want. The mutation happens. After the string, which is the query, you'll see a map. That is, new person is the name of the variable that contains my input object. And that's at values, which is just the values out of the form. That's a reframe subscription. Then you see in square brackets, person create result. That's a reframe event that will be triggered when the HTTP request returns. And that's basically what there is to regraph right there. So what this shows you is you can add GraphQL or make something that will talk to a GraphQL server without changing much about how reframe works at all. Because normally that would be sending off some event that triggered an HTTP request. And when it came back, it would have provided some event to be called to handle the results. So it's very much like what reframe would look like without GraphQL. Yes, sir. In this, well, reframe itself doesn't know anything about GraphQL or HTTP, but regraph expects the first argument to the mutation to be that string. Yes, expects the next thing to be the query. Now it can't. This is Clojure, right? It could be a deft somewhere to be that string. It doesn't have to be. It doesn't have to be a literal string. It can be anything that evaluates to that string. Yes. Now the query, the string, doesn't contain any of the data about the form values, right? That's all in the variable, in this case, new person. That's what the $new person thing is about. Unfortunately, the old version of this allowed me to draw on the screen, which is why I was trying to use it. But you'll see you have this $new person. It says it's an input person. And this is called new person. And the GraphQL matches that up. And so all the actual values are matched up from that. Those are GraphQL variables. Does that help? So you're not using, I'm not doing string manipulation or hard coding to put values in, or hard coding values into the mutation. That would be a mess. That's one of the things I was really concerned about the first time I looked at GraphQL. It's like, am I going to have to use string manipulation to build this stuff up, to have it look like, insert into blah blah blah, the values, because I've done that back in the early days of SQL. That's what you had to do. The question marks didn't exist, and boy, those values better not contain bad stuff, because there was no good way to filter that. So it's not as bad as it seemed, but you could certainly create another event, as Ian said, because events can trigger more events. There is special, I won't say exactly, it's not exactly special syntax, but something's equivalent to special syntax in an event to trigger more events. You can use reframe dispatch, but that's heavily frowned upon. If you do it the other way, you actually return a map of the events to dispatch. So it makes it like it's actually like the IO monad. Because this is, the way Reframe works uses a lot of the concepts of that awful M word that we're not supposed to say.
Are Lisp folks allowed to talk about monads?
I mean, that's one, I gotta say, that's one of the things that was really good about Elm. They have a lot of monads in Elm, but you can't create new ones, and they don't call them monads. So I was actually at a meetup thing, and some guy said, "Oh, Elm is so great because it has all this stuff and it does all this stuff, and you don't have to do all these monads." And we just look at, "Oh, that's the IO monad," and you do this, blah blah blah. Oh, that's the maybe monad, but they don't use the word and they don't scare people off. Reframe uses a lot of the concepts of monads, but it doesn't. They're not actually monads. I don't think they follow all the laws necessarily, but they get all the good stuff of monads without all the Okay, so
John,
yes.
going back to the other slide, I was wondering what the relationship is between these mutation strings and the ones you define in the query, and how tightly coupled they are.
The queries themselves have no relationship to the mutations. In other words, the queries can be whatever you want them to be. The mutations can be whatever you want them to be. But you do have to, they're coupled in that it's talking about the same data, right?
No, I meant the mutations that you define in the schema versus these mutations.
They have to be the same. The mutations that are defined in the schema are the only mutations that are allowed.
Right, but here, I mean, like I see you specifying fields.
Okay, so
Person,
I have create, if we went back and looked at the mutations, you would find that create person and update person are defined mutations in the schema. They each take one argument, which is an input person. This thing that goes around it, the one that's camel case, that's really a way to tell GraphQL how to relate the GraphQL variables, the inputs from the form, into the actual mutation. It's confusing. It actually makes sense once you see what they did, but it's very syntactically heavy for what it actually does. It's a way to pass an argument, because if you look down here, this is $new person, and that just tells what type it is, which is required. And then I have this thing, which is actually called a GraphQL variable, new person. So it's matching up $new person to new person in this map. And you can have more than one variable. So it could be new person, old person, address, whatever you wanted it to be.
yeah, what I'm really trying to get at is what is the cost of refactoring this
Never having done a huge project. That's hard to answer, but it doesn't seem very hard. Doesn't seem as hard as doing SQL changes. Yeah, or simply just defing the strings where they can be reused. This is how the example code was written. Yeah, on regraph's example code. But again, anything that can evaluate to the string you need is good. And actually, it's a good idea to def those somewhere so that you can change them as you need it, so you can reuse them, because it's very possible you'd have the same mutation used 3 or 4 different places with different buttons and widgets on your screen. Any more questions on this? Okay. You saw some view code before. One thing is you have to do some initialization. In this case, I chose to query everything, all the people data down to the screen. When I originally was looking at this application a couple years ago for some other reason, there weren't going to be very many people. There's like a maximum of 25 people. So that was a business, a thing for a nonprofit, and that was the size of their universe. So querying everything up front makes sense. This, if you notice the empty curly brackets, those are the GraphQL variables. Well, guess what? There are no variables for the query. If I were querying for a specific person, then I would have a variable that specified which person. I use UUIDs. So it would actually specify a UUID. And that does work. And then it would call people query result. When the data came back, it would dispatch event pure people query result when the data came back. Yes, that's exactly what it says. That's exactly what it says. Yes. If you don't specify any fields, you'll get no data.
That's how GraphQL works. That's like the heart of it, is you're only specifying a slice of the data that you want. Instead of getting the whole user, you get only the fields that the user uses.
Yes, that is, you can specify, if you wanted the events the person was in, you can specify further events, and then in curly braces the stuff you wanted out of each one of those events. So it will join it and send it down to you that way. I mean, this was envisioned as providing data in the shape needed for the view. Back a couple years ago, that was the vision of what this was. And so you would only get the stuff you needed for your view. And if you think about Facebook, they have tons of data, right? And you don't want to pull everything about every newsfeed article down to somebody's mobile app.
Yeah,
So
then you get in trouble with the public.
yeah, then somebody would figure out how to actually go in there and find their AppDB and pull it out and have all your private data.
Is that really possible, John?
It's- yeah, one of the purported advantages of GraphQL is Facebook had iOS clients and multiple versions of those, Android clients and multiple versions of those, the web interface, and who knows what else. Who knows what other APIs they provided. And by using GraphQL and having it come down kind of in textual form like this, it made them easier for them to deprecate the things and figure out what was being used and what wasn't being used, and adjust their API. And they didn't end up having API versions. And if you have, I think they said at one point they had maintained 14 different API versions. to support all their clients, and that gets expensive fast. And so by using GraphQL, they got rid of that problem. And by the way, this could have had the whole thing with the dollar, dollar person and all that stuff. That is allowed in queries, and if you want to specify variables, you have to do that. But they have the shorthand because a lot of times you just want to get data. You can use the shorthand. Now, on the server side, I used 2 libraries around GraphQL, both from Walmart Labs. One's called Licinia, the other one's called Licinia Pedestal, or Pedestal Licinia. And Licinia is fairly well documented, not perfectly documented, but fairly well documented, and it seems to be pretty solid. Pedestal Licinia just makes it easy to set up a pedestal server, which is a Cognitect option to a Ring server. And it's easier to set it up that way if you don't want to serve JavaScript to a browser out of that server. If you want, that particular library, Pedestal Licinia, is designed to create a standalone API server, not something that's going to support sending HTML and JavaScript and things to a browser. Now, you can work around that easily enough, but that's the design. I like Pedestal. A lot of people don't, but it did make things fairly easy. The hardest part of setting up the server, something I don't really have up here, was setting up the CORS processing. Since I had the server and client served separately, then I had to have CORS processing. CORS processing isn't hard. I had to figure out exactly how to configure that. The hardest part of configuring it is when you specify either a function that will take the domain and say if it's okay or not, or a list of domains that's okay. Well, a lot of times you see star used to mean everything. That doesn't work. It does not work with this software. The way to make star happen is just have a function that returns true. And then it will allow all domains. The other thing I found was a problem is the way CORS processing is handled in regraph. Fig wheel wipes out some of the CORS parameters every time it reloads. I could have worked around that by changing how I did things on the server just a little bit and configuring the interceptor slightly differently. That was more involved because this configures all the interceptors for you automatically, which is nice. And it all automatically the Licinia Pedestal library automatically configures the route GraphQL, which is the standard for doing GraphQL, and it makes the / route be graphical, GraphIQL. So if you just go to the / route, you get the nice little UI where you can play with it. You can also, by specifying a parameter to be true or false, turn GraphQL on or off. So you could have it off for production if you wanted that. You may want it on for production if you have an API product and people need to be able to play. Your clients need to be able to play. Yeah. Okay, so basically you build a schema as a file. It's just a text file. So in this case, you call schema compile to compile that schema to some internal thing that Licinia likes. All I did was slurp the schema in, parse it, compile it. But there are some things you have to specify. One is you have to specify something called resolvers. That seems to be fairly standard terminology on the server side. That just says when you get a query, how do I do the query? So you can set resolvers for different things. In this case, for people query, I have a people query resolver and so forth. For mutations, I have those too. All you're doing is telling it for :people, which is a query, use the function people query resolver. There's a standard interface to it. This works really well. Scalars. You have built-in things like string. ID is kind of built into GraphQL. It understands ID by default, but it doesn't know what it is underneath. So I was able to create these things called conformers that actually take whatever it is and turn it into whatever I needed inside. And I specify those here for the, you have a parse and a serialize. So it comes in from GraphQL, you have to parse it to whatever you need it to be. You have it going out, you have to serialize it to JSON, to something that can be used in JSON. Just for whatever reason, just like JSON, they chose not to have a date type that's built in. So I had to create a date type. I used CLJ time and just used the serializers and parsers that are in CLJ time. Worked fine. And if something goes wrong, you just throw an exception and it tells you it's no good at the other end. Yes, I did. Yes, I did. Well, because remember, it's serializing it all to, I serialized it all to ISO 8601 or whatever between. So it could pretty much work with anything. And by the way, regraph is supposedly compatible with Apollo, which is probably the most popular client-side library in JavaScript, or pardon me, yeah, in JavaScript. So it can do the same things as Apollo does toward a server, supposedly. One interesting thing is you provide doc strings. So this is just a view of some of the doc strings I provided. Person associates these doc strings with it. Then when you use GraphQL, you can actually see the doc strings. So if it's, say an ID is a UUID v3, you can just say that in a doc string. When people start working with the thing, they think, oh, it's a UUID v3, okay. Otherwise, it shows up as something that, oh, that's a UUID, but you don't know which version it is, right? And various things like that. Or what's this? You know, I'm seeing up here, I'm seeing some text numbers. What is that thing? Well, it's good to be provided doc string so people can actually understand what it is they're supposed to do. Okay, this is one of my query resolvers. It's pretty simple. You have a context, which is, it has a whole bunch of stuff in it, some of which is internal. It contains all the fields for the query, and if you want the resolver to do something with authorization, authentication, and so forth, you would put stuff in the context to allow it to do that. So you have context, you have the arguments. Those are literally the variables that we had on the front end. And then you have the resolved value. The reason you have resolved value is these, as you can guess, this can be a recursive process, or at least a multi-level process. So it'll pass the resolved values up and down the chain. Okay, so this one, remember I could do the subquery. That's what the executor selects field is. I look at the context and see, does it have the events field on a person in it? If it does, I have to call get person with events. This is Postgres underneath, so it simply does a join. Otherwise, it just get person. And it will automatically, Listenia automatically matches up the GraphQL field names we asked for with the field names that came back from whatever did the query. So if you make those the same names as field names in the database, it will automatically match them up. If you specify field names that don't exist in the query, in the schema-defined query, you will get an error message. You will get errors back. It will not execute the query. It won't even get to your resolver, which is good for security. It filters it all out up front. That's something I was really concerned about. They have I think an Antler 4 parser underneath this thing that takes care of that kind of stuff for you. And you can, if you get one thing I don't like so much is it does a lot of things with exceptions. I prefer to do more of a monadic approach, but you can use resolve as to pass back errors. And it will take all the error messages and consolidate them into the errors key of the map that's passed back, which again gets turned into JSON on the way over. And I have a mutation resolver. It's essentially the same thing as the query resolver, except that I have to update the database. In this case, it does an insert. I make sure if somehow role wasn't specified, even though it should be, I make sure it becomes client, which is the thing that's not going to hurt you, right? If you make somebody accidentally an administrator, that's a problem. If you make somebody accidentally a client, probably not a problem. Then I printed adding person, and I insert it in the database. In this case, the ID cannot be specified, or if you do, it's a problem. So before I get here, I've actually dissociated ID, and I configured Postgres to automatically generate a UID in the record. Okay, type conformers, they're very simple. In this case, I'm doing the UUID stuff, and I just convert UUIDs. And that's basically how it works. It was an interesting project. The code was, there was a lot to figure out, but in the end, the code was not very complicated. I was really pleased with the code not being very complicated. The only thing I think I didn't show you is the events that are triggered when data comes back from the server. And all I do is update the appdb based on ID. I have it all normalized by ID, and it just stores it by ID. So no big deal there. So any more questions? Yes, sir. Yes, that I chose not to do that because I didn't need to, but you can do that by you can specify which records you want by just using variables. You know, I can tell I want records 1 to 10, 2 to 20, or the next 20, because queries are whatever you want them to be. Yes. I'm sure you could make that work. The way these libraries are designed are really around eager handling of the data. I'm sure there are ways to do it, though. Yeah. Yeah. Yes.
It's really all about the schema you're applying as well as the client. Like it doesn't give you anything for free, so like if you have to implement your own pagination strategy, there's different.
Yeah, you'd have to pass some kind of identifier that could be serialized, right? Because you have your own serializers and deserializers, so it can be whatever you can figure out how to turn it into text. Well, the database, some of that's going to depend on the database that's underneath it, right? If you have a database underneath it that doesn't sort, that's going to could be really difficult, especially if it's a large data set. Yes, if you're dealing with a typical SQL database, I know that at least a few years ago, Facebook had like 1,000 MySQL instances out there, and they somehow tied them together. I don't know how, but you could then use the underlying MySQL pagination and sorting mechanisms to do what you needed to do.
So just to be clear, call out what we're beating around the bush on. This is going to help if you're using Datomic and you don't have pagination.
That's correct.
Services if your underlying data store doesn't.
I mean, many data stores do provide, even Mongo provides sorting and pagination. Yes, which is okay. It's just you have to know what the trade-offs were.
It would be cool if
You could Yeah, it's not going to automatic. There's nothing that's automatically going to cause dynamic tab sorting.
I believe in magic.
I know you can. There's some capability of stored procedures. Maybe you can figure out some way to sort procedures sort. Anything else?
Someone other than me, come on.
I have a question just about
Yeah.
how do you keep the app DB in sync with the, like, is it every time you mutate? So then that updates?
Well, okay, so there are choices. Reframe is not an automatic caching system. I've seen one in JavaScript that actually does that. They expect Mongo on the back end. They have some kind of mini Mongo that runs in the browser or in the client. It starts with an M. I can't think of the name of it now, but
Couch?
no, it's a whole framework for JavaScript. But anyway, you have to, if you want to treat it as a cache, you do it yourself. I chose to use, for this example, and what I had originally based this on, is to not use optimistic updates. And with GraphQL, when you send your mutation, it also has a query that's tagged on the end. So I just queried the data right back. So when it does finishes the mutation, mutations have a return type. The return type was whatever type I mutated, and I query that back. I get it. So I don't have to go send off another HTTP request to query it back. I've been there and done that. And so that would keep the AppDB relatively up to date. The subscription mechanism, if you're worried about multiple people changing something, you could use the subscription mechanism for that. Basically, that sends a query to the server is supposed to respond to whenever the underlying data changes. Now, you have to program that, right? It doesn't automatically know that your Postgres database got changed. So you'd have to put some hook in so that when either Postgres did something or when you were updating the database, it did something, and it should automatically send that down the WebSocket. In the case of regraph, there's an event that's fired with the data, right? You just take that data and you put it in your AppDB, which is a lot easier than a lot of things I've seen, but you still have to program it. I haven't seen any that I think were fully automatic.
If the mutations were to the things labeled mutations, they might be fire up an event.
And they are. The mutations are confined. The only way you can update data from the client is by firing a mutation. You can't, there's no side door. Now, right, if you have a server-side database, somebody could always fire up SQL and update blah, 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 blah. And there's nothing you can do about that. The other thing that I did not do here, but I have done in another context with ClojureScript, is you can use DataScript. DataScript has, I haven't used these, but I've seen the code. There are backdoors in DataScript where you can have things that are essentially callbacks when something changes in DataScript. And you can use that to try to keep some server thing updated in an optimistic update fashion. Right? One of the problems with optimistic update is you have the temp ID problem. If you do what I did here, you send off the mutation, you create a new thing, you get it back with the ID. If you're using IDs locally and you create something and you do it optimistically, you have to invent a temporary ID that's used, and when you get your data back, it'll have to tell you what that changed to, what the real ID is, and you have to go update your database associated with that, which is all doable. It's just work, and you don't want to do that unless you need to, because there's a lot of places to go wrong. Yes.
The ID would be set.
The way I
in the
handled
mutation.
the way I handled it was very simple. I have the query. I just call the query function, and that's my return. if I didn't blow up inserting into the database, I just call the query.
But you're also assuming that happened.
Given that given that I did the insert and the insert returned okay, or didn't get an exception, because I use Korma. Korma definitely works by exceptions when things don't go wrong. I didn't get an exception, I got a return. I think it's fair to assume that it's at some level in the database.
Sure.
You know, it might be in the cache and not written to disk or something. You don't know that. But then I call the function and it just pulls it out. So it was simple. There are much more sophisticated ways you can do it, but I had no reason to do any of those. I could have spent 3 months doing all that stuff to try to get a presentation together, but I probably wouldn't do that in an app until I knew it was needed. Because again, it creates a whole bunch of ways for things to go wrong, and I don't want to do that if I don't need to. And by the way, when I have people and I want their events, or events and I want the people, I just call. Well, in this case, I was able to tell that it did that. I just called a different function that had a join in it.
Yeah, so I was going to. Queries as well, so we can get events.
Yes.
And that's where the resolved ID, the resolved args, I think is what you call it in your parameter list.
Yes.
And we'll use that so.
Yeah.
And we'll then join them up to the client.
One thing I didn't talk about is Licinia can be run in async mode. I didn't do that because to put everything in, use core async. Licinia has core async and ClojureScript built into it. It uses them extensively. From what I can tell, at least ClojureScript is used extensively. And it does use core async, and you can use core async with different resolvers and send things off and do stuff with them. And there's good reason to do that if you have the performance issues that require it. That's one of the nice things about the library, and the nice things about Pedestals. Pedestals was built around having the ability to be async. Ring has been updated to have async that looks a lot like Node.js by having the three arguments in the middleware. Yeah.
So let's say like the subquery events, fetching the events failed, but fetching all of the attributes for the people succeeded. Have you done anything around like retrieving all of that data but not the events, and UI update saying the events couldn't be fetched but here the person?
No, I have not.
Okay.
I can, in some sense, it's mechanically relatively easy because you can send back errors, and regraph takes the errors part of the JavaScript JSON object for errors and provides it to the code. It's called it, so you can, if you have errors and data that came back, you can provide both. And then the client has to figure out what to do with it. Right, because you don't know what the client's going to want to do with it if you're on the server side, unless you're doing full stack and doing both.
The query kind of.
The query.
Yeah, something.
Oh yeah, there's a parser. Yes, Licinia has a parser. I think it's Antler 4 that parses the GraphQL. There's basically a structure in the context that has the parse stuff in a Clojure data structure. So if you wanted to, you could actually go through and walk the tree.
Does that get turned into database?
That's what the resolvers do.
That's the magic part.
Do you have code to show?
Yes.
Or did you already show the code?
I already showed the code. That's okay. Obviously, I didn't explain it well enough.
Well,
No.
that's basically what your resolver does. It takes what your client turns that into your SQL or whatever.
Okay, so if you look at this slide, I have resolvers, and I have queries and mutations, and any field can have a resolver. Okay, so you can make any field do whatever you need it to do. In this case, the people query, I was going to select star from people, basically, is what the query is. And if I return all the fields, Listenia will filter out the ones that weren't asked for and not send them back. I could have looked through the structure and figured out which fields were actually requested and just returned those. And Listenia would send it back. But in the setup, you attach the resolvers, query people, and then have people query resolver. People query resolver is a function that I specified. Query resolver. This is for one person, but this is person query resolver. And ultimately, it calls something in my DB namespace, which just does a SQL, just uses Corma to do a SQL call. And it returns a Clojure data structure, Clojure map, with the data it was requested for. But you have to figure that out. If you have this whole thing with resolved value has to do with if you have resolvers at multiple levels. Like maybe you have the people query, and then you have some other things that have sub-resolvers in them, which is what we're talking about over here. You can do that because the resolve value will tell you what the other resolvers have resolved, and you can use that data if you want to. But it's not automatic. This is one of the things I had to figure out and understand how it actually worked and how you could do it, because when I originally thought GraphQL was this totally general query mechanism, it's like, how would you ever do that? You have to write a whole SQL database to do anything. But the answer is the queries and mutations are only what's specified in your schema. So you only have to be able to handle those.
There is, because it's all this eco loading, so that the query expands out to be a tree.
Yes.
The retrieval are, if I always presumably like a depth first thing, data back.
Yes.
Right now. But then there's nothing out of the box that doesn't like just end up running the same query. Tree.
Yeah, you could make it do what you're thinking, but it's not automatic.
So
just to be clear, because the way the resolvers work, because they're just functions, the data doesn't have to come off of one single data store. Right? You could have some stuff in a SQL database. You have some other stuff in Redis. You have something else that's coming from an API call, and that's when you start to need to use the async stuff, because the stuff that comes out of your SQL database, unless it's huge, you get it back in a few milliseconds. The stuff that comes off of an API may be 5 seconds, depending on what it is and what the conditions are. And so if you don't use async, you can get into it can be a problem.
To the actual query, you said something about like select star from people.
Yes.
But the client only wants last name. So so is star actually executed, or is it just first name and last name?
It depends on your resolver. I did select star for people. People only has a few fields. Doing 2 fields versus 4 fields out of a thing that has 5 fields is trivial, right? It's not worth the effort.
Right.
If I had a thing where each record was 10K bytes, then it's a different story. And the answer is you can go into the context and see what was actually asked for. And that's why I have one of these resolvers. Here it is. I have if executor /selects field. That lets you test whether a certain field is actually asked for. So if you only want to worry about one field that's complicated, you can just use that. Otherwise, you have to go walk the tree. But there is a tree you can go walk of the query. and just get what you want. And but Licinia will filter out the stuff that wasn't asked for and not send it over the wire.
But, like, on the client, you can ask for anything from the people table, as long as it's in the schema.
Yes, as long as it was included in one of the types of the schema.
So how do you handle that in the resolver?
Well, if you don't have to worry about the table, the records being really long,
Yeah.
the easy thing to do is just do select star, and Licinia will filter out the stuff you wasn't asked for. If you have fields that are huge, have some blob that's huge, you would want to not ask for that, right? That's not usually the big runner case, but it is a case, and you can use this executor selects field, or you can walk the tree, because the tree is in the context. But unless it's a big query, that just doesn't make sense to do that. Go that work.
Jeff, you also
Like that polling cleanly.
picture that.
The way we used to do it when we had to build SQL queries by hand is if you have you can just pull a list of the fields we're asked for. That's easy enough. It's easy to find them, and you have to do conceptually you're doing string manipulation to put it all together. If you're using, depending on which SQL library you're using, if you're using JDBC directly, you're going to use string manipulation to put it together. If you're using, knowing that invalid fields have already been filtered out, that function is actually done for you. If you're using Korma, it will do some of that stuff for you. Because you can pass it I forget if it's a map or I think it's actually a vector of the fields you want, and it will just pull those fields.
Right.
So that would be relatively easy to do. If you have multiple levels, now you have to be a little more careful because you have to make sure you're not doing levels you don't want to do and things like that. If you have multiple levels, that's probably the join if it's a SQL database, and you may have to do something different there. Again, Korma is pretty good about being able to fairly cleanly put things together to make a SQL query. It's harder if you're trying to build it with JDBC because it's string manipulation. Yes, we had another question back here. Okay. Going once, going twice, going 3 times. Thank you very much. I hope I didn't waste your time.
Thanks, John. I appreciate you speaking for us. Just wanted to also make sure to thank our sponsors. We have this beautiful classroom to use that is from the Turing School of Software Design. They do a great job training people up. I've had the pleasure of interviewing numerous folks from Turing and have always been impressed with the quality of the education that they get here. Also want to thank KJ Technical for the pizza. And lastly, I want to thank Cambium Consulting, the consultancy I work for, which is helping to pay the dues and